Hello and welcome to the last certification on freeCodeCamp. I can't believe that we reached so far. It's been an amazing journey, and this is the end. We just have one more certification, which in my opinion is the hardest. I looked over the projects and there are a lot of stuff to do on them, which is also good because this way you can see some harder projects. Not so good for me because I'm going to spend countless hours to fix them and solve them, but it will be good for you who are watching. Alright, this one is called Information Security and Quality Assurance Certification. And in this live stream, we're going to look over information security with HelmetJS. There are only 14 subsections. There are only 14 challenges. I'm not sure how to call these. Alright, let's see what is this about. To be honest, I haven't used HelmetJS. Next one is Chai. I haven't used Chai also. I think that's how you pronounce it. Quality assurance and testing. This one is a good one. And then we have Advanced Node and Express, which should be interesting. Passport, template engine, hashing your password. Yeah, it looks interesting. Alright, but until then, let's see what this project is about. Well, what this section actually. HelmetJS is a type of a middleware for Express-based applications that automatically set HTTP headers to prevent sensitive information from unintentionally being passed between the server and client. Hello Ashish, welcome to the live stream. While HelmetJS does not account for all situations, it does include support for common ones like content security policy, XSS filtering, and HTTP strict transport security, among others. I have no idea what these mean, but that's a good thing. I'm going to learn something new. HelmetJS can be installed on an Express project from npm, after which each layer of protection can be configured to best fit the project. Hello Kavit. Ashish, please make a TensorFlow.js tutorial. First I need to learn it and then. Working on these challenges will involve you writing your code on Glitch on your starter project. So yeah, this is what we've been doing on the last certifications also. So yeah, okay, start this project on Glitch using this link. Good. Let's see what this is about. Come on, Glitch. Taking a while. Man, refresh. Alright, let's see what we have. Server.js, do not edit. So okay, this is from their part for testing probably. Then package.json, we have Express. Okay. And we have my app.js. Okay, again we have a bunch of text here which we're going to go over. Do not edit, do not edit. Okay, applied infosec challenges. Okay, installer require. Good, so I think that's the first lesson. Installer require Helmet. As a reminder, this project is being built upon the following starter project on Glitch, or cloned from GitHub. Helmet helps you secure your Express apps by setting various HTTP headers. Okay, install Helmet and then require it. Good, so we need to install it. Let's add the dependency here. Helmet. Let's search in Google. to see what version it has. Usually when you work on Node projects, you install the packages with npm, but for now I'm just going to copy the version, put a hat there, not sure which, same caret, put a caret there, and we should be good to go. Oh, can I do this? Helmet? Whoa, I can. That's neat. Let's see something else. React. Click. Whoa, that's cool. Good. So I didn't know you can do that on Glitch. Awesome. Now we need to go here, not in my app, and install and require. So const helmet will be require helmet. Let's open up our console and see what's working. Yeah, okay, so it does. We also have a view, remix this, and the public, yeah, so some styling and an HTML. All right, let's take our live link and paste it here so we can submit. All right, good. Hide potentially dangerous information using helmet.hide powered by. Helmet can exploit known vulnerabilities in Express node if they see that your site is powered by Express. X powered by. Express is sent in every request coming from Express by default. The helmet.hide powered by middleware will remove the X powered by header. You can also explicitly set the header to something else to throw people off. Okay, set to. Let's see. High potential dangerous information. Helmet that hide powered by. Okay. Oh, so yeah. By default, Express sends this header. Hey, Republic of China. I'm fine, how are you? Is sent by default coming from Express. The hide powered by middleware will remove the X powered by header. You can also explicitly set the header to something else to throw people off. Okay, so I used that. Is this enough? Should be mounted correctly. I think I need to use it, so I forgot that. App.use, because this is a middleware, right? So we need to use it. Alright, good. Next. Your page could be, is this text the same? I think well, let's read it from here, it's cleaner. Your page could be put in frame or iframe without your consent. This can result in click hijacking attacks, among other things. Clickjacking. Hey Ivan, you made it. You kinda do it for all of the last live streams. You made it for all of them, so that's a nice thing. Okay, clickjacking is a technique of tricking a user into interacting with the page different from what the user thinks it is. This can be obtained executing your page in a malicious context by means of iframing. In that context, a hacker can put a hidden layer over your page. Hidden buttons can be used to run bad scripts. This middleware sets the X-frame options header. It restricts who can put your site in a frame. It has three modes: deny, same origin, or allow from. We don't need our app to be framed. Okay, use helmet.frameGuard passing with the configuration object action deny. So yeah, this is interesting actually. App.use, I guess this is also a middleware. Helmet.frameGuard. frame guard, and we pass in action to be denied. Okay, we have an error. What's that? Helmet frame. Okay, frame guard, like that. Is it that good now? All right. Let's see if that passes. Okay, so this basically what I understand is that it won't allow your website to be put inside an iframe, because people could use your website on their website, put it inside an iframe so it will look the same, and then they could put a button on top of your button with some script. Interesting. I am not aware of all these, and I should. As a reminder, oh no, I don't need to read that. Cross-site scripting, XSS, is a frequent type of attack where malicious scripts are injected into vulnerable pages with the purpose of stealing sensitive data like session cookies or passwords. The basic rule to lower the risk of an XSS attack is simple: never trust users' input. Keep that in mind. Never trust users' input. As a developer, you should always sanitize all the input coming from the outside. This includes data coming from forms, get query URLs, and even from posts bodies. Sanitize means that you should find and encode the characters that may be dangerous. So these. Mother browser can help mitigating the risk by adopting these software strategies. Often these are configurable via HTTP headers. The XSS protection HTTP header is a basic protection. The browser detects a potential injected script using a heuristic filter, I guess. If the header is enabled, the browser changes the script code, neutralizing it. It still has limited support. Okay, so use HelmetXSS filter. Okay, you have more info here, which is nice. App.use helmet.xss filter. So that's another middleware. These challenges are interesting with just reading and using some headers, well, changing some headers, using some middlewares. Browsers can use content or MIME sniffing to adapt to different data types coming from a response. They override the content type headers to guess and process the data. While this can be convenient in some scenarios, it can also lead to some dangerous attacks. This middleware sets the X content type options header to no sniff. This instructs the browser to not bypass the provided content type. Okay. So this is like reading a documentation now. It's confusing a little. Well, it's not confusing. They're pretty clear, but yeah. To be honest, I never created an app with these. Probably because I never created that big of an app. So, or I just did a very poor job of securing my web apps. Hello, VDN. Some web applications will serve untrusted HTML for download. Some versions of Internet Explorer by default open those HTML files in the context of your site. This means that an untrusted HTML page could start doing bad things in the context of your pages. This middleware sets the X download options header to no open. This will prevent IE users from executing downloads in the trusted site's context. Okay. App.use helmet IE no open. So IE, please don't open this website, I guess. Alright. HTTP Strict Transport Security, or HSTS, is a web security policy which helps to protect websites against protocol downgrade, against attacks, and cookie hijacking. If your website can be accessed via HTTPS, you can ask users' browser to avoid using insecure HTTP by setting the header Strict Transport Security. You tell the browsers to use HTTPS for the future request in a specified amount of time. This will work for the requests coming after the initial request. Interesting. Configure helmet.hsts to use HTTPS for the next 90 days. Pass the config object max age, time in seconds, and force through. Glitch already has HSTS enabled. To override its settings, you need to set the field force to true in the config object. We will intercept and restore the glitch header after inspecting it for testing. Note: configuring HTTPS on a custom website requires the acquisition of a domain and an SSL DSL certificate. Yeah, so to make it secure. Alright. App.use helmet.hsts, and we need to pass in an object with the first property being max age like that, and apparently we have 90 days in seconds, so 90 times 24, which stays, times minutes and times seconds. Okay, so 90 days in seconds. Can't type. And we also need to add that force through, right? Alright. Okay. To improve performance, most browsers prefetch DNS records for the links in a page. In that way, the destination IP is already known when the user clicks on a link. This may lead to overuse of the DNS service if you own a big website visited by millions of people. Privacy issues. One eavesdropper could infect that you are on a certain page. Could infer that you are on a certain page. Or page statistics alteration. Some links may appear visited even if they are not. If you have high security needs, you can disable DNS prefetching at the cost of a performance penalty. Okay. App.use helmet.dns prefetch control. So we're not prefetching anymore. If you released an update for your website and you want the users to always download the newer version, you can try to disable caching on client's browser. It can be useful in development too. Caching has performance benefits, which you will lose, so only use this option when there is a real need. Alright, app.use helmet no cache. Now this is useful sometimes when you work, well, you can set up caching, so make your website faster so that the users, when they come first to your website, their browser will store some information, so then when they come the second time it will be downloaded much faster, or they already have it. Now that's good, because it speeds up things for the user, but then you will sometimes do an update and then the user won't see that update because it's cached. So they need to force reset your the browser, well, the window, in order to see the changes. So probably this would fix that. Okay, this challenge highlights one promising new defense that can be significantly reduce the risk and impact of many types of attacks in modern browsers. By setting and configuring a content security policy, you can prevent the injection of anything unrelated. No, that's not what it does. Anything unintended into your page. This will protect your app from XSS vulnerabilities, undesired tracking, malicious frames, and much more. CSP works by defining a whitelist of content sources which are trusted. You can configure them for each kind of resource or a web page may need. Scripts, style sheets, fonts, frames, media, and so on. There are multiple directives available, so a website owner can have a granular control. See HTML5 rocks. See, not see. ECDN for more details. Unfortunately, CSP is unsupported by older browsers. By default, directives are wide open, so it's important to set the default SRC directive as a fallback. Helmet supports both this default SRC and default -SRC naming styles. The fallback applies for most of the unspecified directives. In this exercise, use Helmet Content Security Policy and configure its setting the default SRC directive to self. The list is allowed sources must be in an array. The list of allowed sources. Okay. In order to trust only your website address by default, set also the script SRC directive so that you will allow scripts to be downloaded from your website and from the domain trustedcdn.com. Hint: in the self keyword, the single quotes are part of the keyword itself, so it needs to be enclosed in double quotes for to be working. Okay, so we need to use app that use Helmet dot content security policy what I'm typing, and here we give it a default SRC to be an array and a string with also the quotes of self. Okay, you can see here that we don't have the quotes around. Alright. Middleware should be mounted correctly. Your CSP config is not correct. Default SSC should be self and script SRC. Oh, so we have two. So default and script self and what? Set also script SRC directive so that you will allow scripts to be downloaded from your website and from the domain trustedcdn.com. Helmet. Okay, so what's not working? Helmet.csp. Oops. CSP. Now that's interesting. Okay, HelmetJS CSP. Helmet. Oh, okay, so directives. We need to add this here. So that's an object. These are the children's, and this shouldn't have the quotes. Alright, now is that good for you? Helmet content policy, directives, default, style src. Come on, what's wrong? Oh, changed it now to that. Okay. Come on. Yeah, so that's it. App use helmet will automatically include all the middleware introduced above, except no cache and content security policy, but this can be enabled if necessary. You can also disable and configure any other middleware individually using a configuration object. Example, helmet, use helmet, frame guard, content security policy. Okay, DNS prefetching, disable, okay. We introduced each middleware separately for teaching purposes and for ease of testing. Use the parent helmet middleware is easy to implement in a real project using the parent helmet. Okay, so I guess what's next? Oops, I need a link. What is HelmetJS? Good question. We're just learning about it. Okay. Apparently is a package which helps us secure our web application. Okay, for the following challenges you will be working with a new starter project from the previous one. You can find it here. Alright, bicrypt hashes. Now that's interesting. Good for working with passwords. Okay, express body parser, app, solve. My plain text password, okay. Start sync. Alright. Good, let's see what this is about. Bcrypt. Hashes are very secure. A hash is basically a fingerprint of the original data, always unique. This is accomplished by feeding the original data into an algorithm and returning a fixed length result. To further complicate this process and make it more secure, you can also salt your hash. Salting your hash involves adding random data to the original data before the hashing process, which makes it even harder to crack the hash. Bcrypt hashes will look like this. Look at that password, which does have a structure. The first small bit of $2A is defining what kind of hash algorithm was used. The next portion defines the cost. Cost is about how much power it takes to compute the hash. It is on a logarithmic scale of 2 to the power of cost and determines how many times the data is put through the hashing algorithm. For example, at the cost of 10, you are able to hash 10 passwords a second on an average computer. However, at the cost of 15, it takes 3 seconds per hash. And to take it further, at the cost of 31, it will take multiple days to complete a hash. The cost of 12 is considered very secure at this time, the last portion of your hash. Look at that. Looks like one large string of numbers, periods, and letters, but it is actually two separate pieces of information. The first 22 characters is the salt in plain text, and the rest is the hashed password. To begin using Bcrypt, add it as a dependency in your project and require it as Bcrypt in your server. Okay, const Bcrypt equals require Bcrypt, and we also need to add it. So Bcrypt. All right. Good. So basically this package allows us to crypt the password. When you want to make a website which will have user identification, you would want to encrypt the password received from the user. It will give us something like, I don't know, my cat is beautiful, and you want to store the password crypted, not what the password the user gave you. So don't ever store plain passwords to your database. Alright, oops, let me get the link. Paste it here and submit. Okay, we're close to be done. As hashing is designed to be computationally intensive, it is recommended to do so asynchronously on your server as to avoid blocking incoming connections while you hash. All you have to do to hash a password asynchronously is call bcrypt.hash. You pass in the password, the salt, and it has a callback function where you can store the hashed password to the database. Add this hashing function to your server. We already defined the variables used in the functions for you to use, and log it to the console for you to see. At this point, you would normally save the hash to the database. Now, when you need to figure out if a new input is the same data as the hash, you will just use the compare function. So this hashes and this compares it. Add this into your existing hash function, since you need to wait for the hash to complete before calling the compare function. After you log the completed hash and log res to the console within the compare, you should see the console hash then true is printed. If you change my plain text password in the compare function to some other plain text password, then it should say false. Okay, so we gave it a password with a salt, then we console.log it, and then we can compare. Okay, giving the password, the hashed password, and see the result. Okay, so let's look at all the people subscribing. That's nice. Hello, welcome to my channel. Okay, so let's do hash and we can use here the password they provided, the salt rounds. Okay, we're getting the hash, and here again the main plain text. Now let's see the console. You can see this is the password which is generated, and then here we're consoling to see if the result is true of their comparison. Okay, oops, copy the live link, paste it here, and submit. Now let me go over again. So bycrypt hash, and you paste in the password which comes from the user, and also the salt rounds. In this case they use 12, and a callback function which will give you the hashed password. This you will store to your database. Next, when you want to compare to see, for example, when the user wants to log in, you will get the password he provides again and check it with the hashed password, and then you use this compare function, and it will say if it's the password is true or not. If it's false, you can just say the password is wrong or something. S25 20, not 25. S27, hi, welcome to the live stream and welcome to my channel. I saw that you just subscribed, which is awesome. Okay, we can also use bcrypt.hashSync and comparesync to do it synchronously, but can cause lag if using it server side with a high cost or with hashing or done very often. Okay, so yeah, that's basically the difference between the two. Let me put it here, and also let's use this. So basically this is asynchronous, which will won't block your server, and this is synchronously, so it will wait until first it will hash the password, and then it will wait until it will compare the password. Alright, we can check this, but the result will be the same as here, so not it's just it will be the same, so we shouldn't test it. Well, alright, this was an interesting section about information security with Helmet, and we learned about bcrypt, which is useful. I haven't used Helmet before, but probably the best way to use it is to configure it like this. So just pass in the Helmet and it will do all the hard stuff for you. And then if you want to add some more stuff, well, you can just give it an object with all the properties. Alright, that's it for this section. Next up will be quality assurance and testing, which should be fun. S27, you're new to the channel. Hi, welcome to the channel. Hopefully you'll find great content here. Alright, this is it for this live stream. I'm going to take a break and come back a little bit later with this section of quality assurance and testing. See you there. Bye.